Assalamualaikum. My name is Shazly Iman bin Shamsul Fansury, and I'm a final year student of computer science in Bioinformatics. So here today I'm going to present to you about my continuous of my final year project. And from the previous final year project one, was conducted a year ago. So today I'm going to present to you the next phase of the final year project. So today I'm going to present to you my research, which are machine learning classification approach for COVID-19 ICU admission. So moving on to the next one is the first chapter. And the first chapter, I'm going to discuss about the introduction and also the research problem background. So on the research problem background is, as we know that COVID-19 variants are becoming more accessible to the masses of worldwide. So as we know that from the COVID-19 or any variants or disease or cancer is highly and unlikely can be integrated into worst case scenario. So from the right side of the image, you can see is the structure of morphology coronavirus illustration was from Jennifer, and is the closest range of how the virus how the variants look like. So as we know that COVID-19 is a respiratory ailment caused by SARS-CoV-2 virus that was first detected at Wuhan region of Hubei, China. So COVID nowadays are getting control, and if it, if it's not under control, it can be emerge into uh, worse worst case, which as you can see on nowadays lately on Singapore uh, getting the outbreak of COVID-19. So on the below of the image of the coronavirus, you can see is the illustration knowledge of machine learning, deep learning, and also AI. So the research shows an in-depth of evaluation of existing modern methods for machine learning and deep learning researchers, as well as explanation on how machine learning, deep learning can enhance in the future for understanding COVID-19 and also prevent the outbreak from itself. So on this propose of the research is to use machine learning to classify COVID-19 ICU admission. So on the problem background, as we can see, is the problem is the COVID-19 in-depth of evaluation exists in modern methods of machine learning and deep learning researchers and the overall health community. So on the next problem background is impact of economic and also services. So as we can see, the epidemic of research has also collected that it also impact the education, businesses, hospitality, economic, and also forces schools or institution to shut down in order for them to have a lower cases and also reduce the emergence of COVID-19 spread. So lastly, on the problem background is what we are main focus on is the developing effective health measures. So nowadays we know that developing health measures are very hard and also kind of complex and also difficult for us to understand. So on this case, we know that COVID-19 identification and classification are essential, important to develop effective public health measure to reduce the effect of drastically on ICU admission, especially. So it was developed from the blood test and also from the result itself. We are going to modify it and also analyze it from the doctor's prescription and also from the machine learning that I gave us the result from it. So on the research questions and objective. So the research question is to achieve a reliable and accurate classification of COVID-19 ICU admission. So in the general, it is not possible to train a machine learning or deep learning system to make a prediction with 100% accuracy. On the other note, algorithm performance of classifying COVID-19 based on factors to determine the best method, algorithm, XGBoost, and also random forest. So the objective of this research is to investigate COVID-19 for ICU admission to make a precise classification for COVID-19 ICU admission. On the other hand, to determine prediction on the COVID-19 ICU admission through symptoms dataset using random forest classification approach, and also to evaluate the accuracy of classification result determine the best parameter on the classification. On the research scopes, we use the Google Colab to implement a training dataset as well as for random forest and also XGBoost to see whether which one has the better accuracy. So on the applying on the random forest, it applies a random forest classifier for anticipate the values of any additional data for high accurate prediction, as well as apply on the XGBoost for higher accuracy and adaptability of a wide range data type of data structure. So moving on to the chapter 2 is literature review. It is supervised learning, which are conducted on random forest and also XGBoost. So supervised and unsupervised reinforcement. So these all are being made on the machine learning concept, and every attribute has their own learning paradigm, intentional machine learning, and also decision making processes. So the performance comparison that we are going to make is from the matrix value itself, and the matrix value are being gained from the structure of confusion matrix. So what are the confusion matrix? So on the confusion matrix, we can see the true positive, false negative, and true negative. So what are we going to discuss from the confusion matrix? Yes, we are going to discuss four things, and we are going to gain the four result of it. The first one is the accuracy, in order for accuracy, precision, recall, and also F1 score, known as Z score. So on the accuracy, we know as with the accuracy is to measure how effectively it predicts the outcome of the class label dataset. For the precision, is a statistic to use to assess the performance of learning model, notably in classification tasks. So on the recall, it was on classification problems, and for the F1 score is the overall of the whole accuracy, precision, and recall, and make it into abundance of statistic that combines model accuracy and recall into a single score that may be assess the overall performance to the model. So the software that I use is Google Colab for determining my dataset, and also from the dataset I gain is from the Kaggle. So on the research methodology, I have three phases. The first phase is identification of dataset feature selection to train machine learning algorithm. So in these phases, we going to discuss research study, problem identification, and data selection. So on the next phase is development of COVID-19 IC admission and classification model. So on this phase, we are going to see whether the dataset is utilized to train the required machine learning model using specific methods from their each method itself, and also to find the essential patterns and correlation in the data. So on the last one is phase 3, which are performance comparison of trained machine learning model. So on the machine learning model that we going to use is random forest and also XGBoost. So on these two, we are going to compare the accuracy, precision, recall, and also F1 score from their confusion matrix, and we are going to gain them which one has the better accuracy in classification model for ICU admission. So here is the research framework that I conducted. So the first one you can see is the first phase. So on the first phase, it has gained the problem and also the identification of the research, and then we're going to do a pre-process from the dataset itself, and then moving on down to the define the training set. So here we are going to move the bigger picture, the bigger part of it, which naive bias is a big figure is a big figure for random forest. So is under the naive bias, and also random forest and also XGBoost. So here is the development of COVID-19 ICU admission and also classification model. So on the last phase is going to train is the comparison of the matrix value for both of the machine learning. So on the research, on the chapter 4 is the research experiment. So on this first phase, I'm going to show to you the picture of a original dataset from the Kaggle. So as you can see, inside the data, there's a null value, null blank spaces, which are very hard for machine learning to train. So in order for machine learning to understand and train them, so it will count the it will fill in the blanks using numerical, and what it calculate is the least mean. So it will be filled by mean. So mean is from the calculation of statistic. So the read highlight is the empty value of uh, non-existent from the data, from the original data. So after we made a data handling of the missing value, so here is the result. As you can see, the least mean is the 0 and 0. At least it won't be empty, so it has a null value instead of 0 blank spaces. So after we handling the missing value, we pre-process and also we make a overall features of results. So this dataset contains a lot of uh, dataset, and from these overall features, I make a conclusion on it to make a top 10 features result based on the feature score obtained. So on this top 10 is highly, highly contributed in finding the feature importance, and also feature importance from this top 10 is different from this all of this. So this is the top 10 result, because from the from the research itself, it shows that to gain these are the information that are important to for this dataset. So here is the respiratory rate max and also respiratory rate difference and mean, and then the blood pressure, respiratory rate blood pressure. So as you can see, at the end of it is the max mean and also max mean median. So in order for them to calculate the statistic result, here is the main part, and the importance is of the score is the the score obtained from this. So on the machine learning algorithm, on the first top 10 conversion metrics obtained for random forest is on the left side is top 10, which you can see the true positive is 256, and also false positive for 22. And then moving on to the next one, and the right side is the top 20. So as you can see, is the same. So the true negative is 67, and the true positive and false positive. So false positive is 22. As you can see, why is it like that? Because it's a metric X. So here is the top 10 features again from the conversion metrics. So top on true positive 256, true negative 67, false negative 22, and false negative 40. So this is the top 10 features and also the top 20 features to see whether which one will contribute and also give a result on the difference on which one is better. So on the score, we can see for the top 10 is for the accuracy is 0.8, and for the precision is 0.75, and for the recall is 0.62, and for the F1 score on the overall is 0.68. So for the top 20 features, for the accuracy is 0.83, and for the precision is 0.75, and recall is 0.58, which we can see the least it can going to reduce, and also random forest to handle big data. So for the overall, it gains 0.65. So on the machine learning, on the next machine learning model is XGBoost. So XGBoost, on the left side is the top 10 conversion metrics, and on the right side is the result of the top 20 conversion metrics. So here what we can see is the top is the conversion metric stored from the XGBoost. So you can see this is the value of it: 266 true positive, true negative 65, false positive 12, and false negative 42. So for top 20 features is 256 true positive, 67 true negative, false positive 22, and also false negative 40. So the metric score, let's see the difference between random forest and also XGBoost. So the top 10 features is accuracy 0.85, precision 0.858, recall 0.859, and F1 score for overall is 0.85. As you can as you can see before. So this is the random forest. You can see 0.8, 0.7, and 0.6. And when it comes to the XGBoost, is it goes 0.8 on all four of the factors of metrics value. So on the top 20, you can see 0.83 for the accuracy, 0.75 for the precision, 0.62 for recall, and also on the overall, it gains 0.68. So let's discuss the result based on the two metrics scored from XGBoost and also random forest. So on this result analysis, we gain that compared to the random forest and also XGBoost model, predicting that ICU admission reveals the XGBoost is superior classification approach. Random random forest achieved 256 and so on in the conversion metrics, which scored them for the accuracy of 83% for the accuracy. For the precision is 75.3%, and recall for 62.6%, and for the overall F1 score of 68.4%. In the contrast of XGBoost gained a higher accuracy of 85.97%, precision of 85.82%, recall of 85.97%, and for the overall of F1 score is 85.19%. So these matrices demonstrate shows that XGBoost more accurate in identifying the patients who do and do not need for ICU, so resulting in a fewer less of false positive and false negative. And as per highlighted, this makes the XGBoost more precise and reliable model essential for improving ICU care. Let's see why XGBoost is better than random forest. So XGBoost, as we know that XGBoost stands for extreme gradient boosting. So extreme gradient boosting is a method of boosting called to boost the model, focusing on the hardest to predict and classify. On the other hand, it uh, prevent overfitting of to ensure the better performance of a new data income. Handling missing values automatically make it smart guesses without need pre-processing. Speed and efficiency, it speed up and also have a efficiency on gain training and prediction, handling a larger data sets in complex of a model faster, and learning from mistakes. It creates trees after trees, and also in order for trees after trees, it fixes before the trees in order for the next tree to move forward. And it also has a flexible which can allow them for a more precise and also have a better performance. So on the conclusion is the review of a literature of COVID-19 ICU cases, analyzed classification has been conducted and discussed. So on the chosen algorithm has been deployed on two of the machine learning, which are random forest and also XGBoost. And also on the random forest is for the frequent in research, easy to use, and also for the XGBoost it provides intriguing exploration path on different insights. And for the other hand is the performance settings like the conversion metrics and evaluation are chosen to train the data and to train the machine learning and have a better result on both of the machine learning. And that's all from me. Thank you and have a nice day.